Okay, so this is the beginning of the chapter 7 and chapter 8 stuff. Um, it's still going to be dealing with trigonometry. So the chapter 7 and 8 are of all trigonometry topics. It's just going into more of the advanced stuff and not just looking for angles and whatnot on the unit circle. Couple things to keep in mind. Midterm grades that get put in, so you can look and see where your midterm grade is. It's based on 61% of the pie being done, which would have been what you should have done for chapters 1 through 5 and 6 if you had completed all the topics in those sections. So it wasn't out of 100% of the pie. Most grades are pretty decent. It, some of the grades are a little bit low, just depending on where you came in and how much of the pie and stuff you finished. Most of the tests seem to be pretty good. It's the pie percentage that's really bringing people down. So don't forget, you do have to go through and do those topics and work on those. You will have a couple weeks at the end of the semester to finish up and catch up on any topics that you missed. But by that point, you're going to have all the topics to go back and fill in the holes on. So do try to keep up with the topics each week and get the sections done before you go on to the next week. So if you finish them early, the other topics will open back up. So you can go back and do those, or you can go ahead. So you do have those options. I believe the next chapter 7 and 8 test is on November 4th. So we'll do the review on November 2nd for that. So we've got about 3 weeks before the tests, the chapter 7 and 8 tests are. All right, so I did put up on the website a Trig cheat sheet. Basically, what it has is all the Trig rules and everything that's built in to put on them. The reason I put it up there is because tonight we're going to be using a lot of the formulas and the identity rules. So having a quick sheet that you can look at for those is going to be very helpful. So it might be something that if you have access to a printer, printing it out so you have it able to be done out. The one big thing I will tell you when we're doing most of these proofs is do not try to just get the answer and put it in the computer. Doing it on a paper first and writing down all the steps is going to make your life a lot easier, and then putting it into the proofs on the computer is the best way to go about doing it. So that's the one big suggestion I would have at the beginning here. All right, so the first couple questions we're going to look at is not too overly difficult. It's just simplifying the trig rules. And when we're looking at these, one of the easiest way to do them is changing everything to sines and cosines and then working our way back from those. So on this one right here, we've got tangent of x over secant of x. So tangent is sine over cosine. Secant is 1 over cosine. So if I look at that as sine over cosine times cosine over 1, those cancel out, and I'm left with just sine. So breaking them down into sines and cosines is probably the fastest way to do the first couple identity topics that we're looking at. So this one just becomes sine of x. Let's do one more of those. For most of these topics, I'm going to try to do a couple of them because every problem is going to be different. They're not going to use the exact same rules, exact same steps. So each one of them is going to be a little bit different. So I'm going to try to do a couple of each one of them. So this one we've got cosecant x sine x over cotangent x. So cosecant, I have 1 over sine x, and then I have sine x over 1, and then that whole thing is over cosine x sine x. So in this one, I don't even have to actually go through and so I know those two cancel right out. So that's just a 1. So it's 1 over cosine x sine x. So that just flips. So it's sine x over cosine x, which is tangent of x. So does that process make sense when we're looking at these problems? Or do you want me to do one more of that one? The first couple problems are pretty similar in this one. They just get a little more complicated. All right, we'll do one more of those. So we've got cosecant x over secant x. So cosecant is 1 over sine x, and secant is 1 over cosine x. So I have 1 over sine x times cosine x over 1. So I get cosine x over sine x, which is cotangent x. And in this topic, everything you're doing is getting it down to one trig function. So if you can't get it down to one mistake, and you're going to go back and look at it. That's why I say writing it all out and doing your steps out is the best way to do these, because there's going to be some problems, especially when we start getting to the proof ones that we're going to look at, where you have to do multiple steps, and sometimes you're going to go down a path that just doesn't work. And going back and going, okay, let me try something else on paper is going to be easier than when you're trying to type it all on the computer and get the steps done that way. All right, so let's go to the next one. So if I remember right, the next topic's very similar to it. Nope, highlight. The next topic goes right into the proof ones. All right, so the proof topics, so there's a couple topics where they give you all the steps and they just want to know the rules. So those are the first ones you're going to work at. The next couple topics after this one, you're going to go through and do every single step out. So we do want to look at the differences between those two. You want to look at the first ones where they have all the steps done out, because those are going to give you the key to being able to do the process later on, because this is how they want it to look, basically. So this first one, we want to look at what changed from each one. So if we look at this first one, that the only thing that's changed is that, and that's not really a good way to do it. So that cosecant squared x minus 1 became a cotangent squared x. My sine x stayed the same. So if we look at the trig cheat sheet that I have, and let's see if I can do this so you can actually see this too. Let's try. Do you see the trig sheet or not? It's on 2 different computers, so I wasn't sure if it was going to actually show up. All right, I'm actually going to get it on my other one. So if the rules that we're going to use, most of them are going to be the reciprocal identities, the Pythagorean identities. The double angle formulas, those ones we're going to use later on, but most of them are going to be these basic identities and then the Pythagorean identities. All right, so now we'll go back to my problem. All right, so for this one, that first rule that they used is a Pythagorean identity. So that one was the cosecant squared equals 1 plus cotangent squared. And it was basically just a modification of that. So we can use, so this was the rule. So what they did was they moved the 1 over. So cotangent squared theta equals cosecant squared theta minus 1. So that's the rule they use. So we're going to look here, and we're going to Pythagorean rule. The other nice thing is if you click the little help button, it's going to list you the rules that are in there. So the quotient rules are there, the reciprocal rules, algebra just tells you it's an algebra transformation. Odd even rules are there too. So you can actually click on and go, oh, yep, that's the one I wanted. Now we want to look at how did it change from that the second step to the third step. Again, the sine x stayed the same. The only thing that changed was my cosine squared x and sine squared x. So in that one, that's a quotient rule. So if we look at the quotient rules, that was cotangent is cosine over sine. And even since it was squared, they both say squared. Now the next one, the cosine squared went to cosine next, but I have a cosine x on the outside. So I really still have cosine squared x. What changed was my sine x. I had a sine x up on top and I had two sine squared x on the bottom. So I was able to cancel one of those out. So that's known as just algebra because we just canceled stuff out. And then cosine over sine is cotangent. So again, that's my quotient rule. So basically, you're just looking at what each step takes to go to the next one. All right, this one, another one of the same type of thing. So we look, I got that sine squared x minus 1. Anytime you're going to see a +1 or a -1 in there, you're probably looking at a Pythagorean rule. So that disappears, so that's a Pythagorean rule. Anytime you're adding in division, most likely it's going to be a quotient rule. Yes, you can use that trig sheet during the test. So this one's going to be a quotient rule. And actually, even on the test, they're going to have those little question mark buttons there. So you could actually click on those too. So they're built into the problem just as easy. But yeah, that cheat sheet definitely helps you a little bit easier organize your notes. Then we did the sine x over the cosine x. Again, this one, same concept. This is an algebra. I just canceled out, and this time, instead of canceling out the sine x, I canceled out the, and then that sine over cosine becomes tangent, and that's a quotient rule. Now, let's do one more of these before we go into the ones where we have to do all the steps. So this one, I got the 1 minus cosine squared x to sine squared x. Again, that's Pythagorean. I'm getting rid of a plus or a minus. Now I got the cotangent becoming cosine over sine. So that's going to be a quotient. And this one, I'm left with just a cosine because the two sine squareds cancel out. So that's algebra. Any questions on those before we go into the actual ones where we have to do out all the steps? Which are the ones that are probably going to take a little bit more work? All right. Okay, so the biggest thing on this one is, notice, they don't give you the steps. So you have to write down every single step for these problems. So my suggestion to you is, do not do it in the problem. Do it on paper. And that's actually what I'm going to do here. We're actually I'm going to rewrite the problem down. Then I'm going to switch over to just a sheet, and we're going to do the problem. Then we'll come back and put the actual answer into the problem. So 1 minus cosine squared x, tangent squared x, cosine squared x. All right. So your goal is to change this side into that side. That's what I'm trying to do. So we're not going to touch this side at all. We're just going to leave that side completely alone. But that's what I'm trying to get the left side of the equation to look like. So let's look at some of the steps that I got to do. So 1 minus cosine squared x, I don't want that anymore in my problem. I don't have a 1 in my answer. So the only way to get rid of that is a Pythagorean identity. So that is sine squared x. So cotangent squared x. And now while I'm doing these steps, I'm just going to put a single letter next to it. A P stands for Pythagorean, A stands for algebra, Q stands for quotient. If you do multiple of the same one in a row, you do not have to put them in the problem each step. So like if I do multiple algebra translations, I can do all that in one step and just put one thing down. This problem, I'm not going to need it. When we get to problem type 3, we will need that step. The next thing I'm going to look at is let's change that cotangent squared x. So this is sine squared x. And this becomes cosine squared x over sine squared x. And that's a quotient rule. Now I have a sine squared x on the top and the bottom. So I cancel those out, and that becomes cosine squared x. And that's an algebra rule. And that's what I wanted. So I am now done. So when we're looking at these problems, now I got to go back to my problem and type these answers in. Okay. So over here, my first step was sine squared x, and then cotangent squared x. And the rule I used was Pythagorean. And notice the same thing. They got that little I mark next to it, and that's going to give you all those rules there too, just to make sure you were doing them correctly. So that's Pythagorean. Here's the best part of all this. You have to click validate every single line you put in. So if you type something in wrong, it is not going to validate. So that means either you made a mistake or you just typed something in wrong. If you've done it completely out on paper so you can actually work down and you know that those steps are correct, odds are you just type something in wrong and it's really easy to fix. So there's actually no real way to get this problem incorrect. So when you're doing these topics, you can't get them wrong because you have to validate every line and you can't check until everything is validated and done. So for example, my next line is sine squared x. And then let's do I'm typing wrong on purpose. And sine squared x. And you notice the only thing I did is I hit a T instead of an S. If I click, so that's quotient rule. And if I click validate, notice how it says this line is incorrect. So I go back and look. Oh, I hit a T instead of an S. So I can just go back and fix that. So it's cosine squared x. And then click validate. And it validates it. So I know that line was correct. The reason I said do it out on paper first is it will validate things even if you don't need to do that step. So if the step you're doing is correct, even though it won't get you to the final answer, it will allow you to validate it. So it's not checking your work and making sure you're going the fastest way. It's just checking to make sure that that step that you're putting in is correct, and that's will work. So my last step is cosine squared x, and that's an algebra step. When I get that, it says your proof is complete. Then I know I'm done, and I can hit check. So that you can't basically, unless you see your proof is complete, it will not let you check the answer. And that's also true on the tests. So when you go through and do it on the test, it will not let you check it unless it says your proof is complete. So if you can't get to your proof is complete, you know you have the answer wrong. But if you can get to your proof is complete, you know you have the answer correct. There's no way to get it wrong. It won't let you put in, it will let you put in wrong things as long as they actually work. So, let me see if I can figure out a way to do one on this one here. So let's do this one, and I'm gonna try to make a mistake that actually is correct and show you how it'll work. So we've got 1 minus sine squared x tangent squared x equals sine squared x. All right, so let's go through and do this one. So again, by Pythagorean rule here. So this becomes cosine squared x tangent squared x. And this is cosine squared x sine squared x over cosine squared x. And now let's say I don't remember that I can cancel things out. So let's do, I'm just going to put cosine squared x sine squared x all over cosine squared x. And then I'm going to cancel those out. So then I'm going to write in then I'm going to do the sine squared x. So this first step, I did Pythagorean, I did quotient, then I did algebra, and then I did algebra. So none of the steps that I did were wrong, but I really didn't need to do that first algebra step. I could have canceled it right out. So when we're going through and typing these answers in, it will let me put that extra step in. So let's see, cosine. And actually, we can even do, like, we could do this. We could do 1 minus sine squared x. And this one I can do sine squared x divided by cosine squared x. And that's the quotient rule. So you don't, it doesn't, as long as the step, like that step works, that step is correct based on what I was doing, like based on the information that's given to me, that will work. So it will allow you to put it in any order in those steps. That's fine. You just don't necessarily have to do it that way. So that's why doing it on paper, you might get a bunch of extra steps in there to get to your final answer, but it's fine. And I did the cosine squared x. But now let's say, oh, well, I know that first one's going to come out to be cosine squared x, and I know it's going to cancel out with the other one. So I'm going to do sine squared x here. And I'm going to say algebra. Because I know that's going to become cosine. I know that's going to cancel out, and I hit validate. It won't let me validate that because I skipped having the Pythagorean step. So I had to do a Pythagorean step, and then I had to do an algebra step. So even though that's correct, and that is an algebra step, I skipped the Pythagorean step, and I have to put that one in there first. So cosine squared x, and then sine squared x divided by cosine squared x. And that's a Pythagorean step. Now it allows that one. And you can do multiple, actually, let me do this. Hitting the wrong button, the computer. So that's an algebra step. and it'll validate, and then I can do the sine squared x, and I got to do the algebra step again. So see how it'll still let you type in extra stuff. It'll allow you to type it in different orders. That's fine as long as the step that you're doing works and all the things you're doing is only one type of problem to it. So not every proof is going to look identical when you check it. All right, let's go to the harder ones. Secant x minus sine x tangent x, and I want this to equal cosine of x. All right, so now this one, if we look at it, I don't have, like, I have a subtraction in there, so I'm probably going to have to do some kind of Pythagorean at some point. But the way that it's written right now, I don't have a +1 or a -1. So I can't really use that to do it. So let's look at the sine of this tangent, because I know the sine and the tangent kind of work together. And let's look at that secant. One of the first things I'm going to try to do is let's put it all into sines and cosines. Once we have it all in sines and cosines, I can put a lot of things together, and let's see what we end up getting. So I know this one's going to be 1 over cosine of x. This one's going to be just sine of x. And this is going to be sine of x over cosine of x. So that right there is a quotient step, because I basically just changed those two into the quotients. Now let's put things together. So I have 1 over cosine of x minus sine squared x over cosine of x. That's an algebra step. I can put these together now. So it's 1 minus sine squared x over cosine of x. And that's an algebra step. Does that make sense?
Yes.
All right. The brave soul. So now the first one. If we look at the first one, now this is one of my Pythagorean rules. So that top one becomes cosine of squared x, and that's over cosine of x, and that's a Pythagorean rule. And now I can cancel those out, and I'm left with cosine of x, and that's an algebra rule, which is what I wanted. So when we type this problem in, I don't have to type all the steps. I only have to type the steps when I changed process. Like the quotient step I have to type in, I have those two algebra steps right here. So if we look right here, I have these two algebra steps right here. I only have to type in that step, because the computer is going to recognize, oh, those are the same things. It's an algebra step. You just did a bunch of algebra work to get down to that part, and that's fine. Okay, so let's go back to the problem. So my first step was quotient rules. So I got to do 1 over cosine of x minus sine x over cosine x, and that is quotient. All right, so it's not letting me put it that way because of I put it on top with the thing. So I've got to do why is that? Oh, I forgot the reciprocal rules. All right, here's a great example of when you do too many things, sometimes they don't always work. The sine over cosine is a quotient rule. The 1 over cosine x is a reciprocal rule. So I actually have to write this as two separate steps. I forgot they had the reciprocal rules on this one. So that's a reciprocal rule. So that's just that one. Now I'm going to type the exact same thing again. Except this time I can do the sine x over cosine x. And that's the quotient rule. So that's a great example of where you're not necessarily doing it wrong. You just didn't write all the steps out. And now I'm going to go from that step and I'm just going to put in this 1 minus sine squared x. Over cosine of x. And that is algebra. And I can do that because that step and that step were both algebra steps. So I don't have to put them in twice. And now I have to do the cosine squared x over cosine x. That's Pythagorean. I can't skip that step and go right to just cosine of x because it's Pythagorean and then it's an algebra step. And then that's an algebra step. And now my proof is complete. So are the proofs starting to make a little sense? So far, you're good.
Nope, never mind. You may answer it, so I'll let you keep going.
Ask. I may or may not answer it.
So I'm just curious about the whole Pythagorean identities. So I'm looking at the sheet that you have, and it's only addressing the 1 plus the cotangent squared. So that holds true across all of the trig functions, correct? Like that's why you're able to do like for your step where you say like 1 minus sine squared. So this holds true like no matter if it's 1 plus or minus and whatever the trig function is.
No. So the reason why, okay, so good question, because I probably would not have answered that one. So for this place, I'm looking at, in this problem, I'm looking at sine squared x plus cosine squared x equals 1. That's the Pythagorean identity I'm using. Now, in the problem, I have 1 minus sine squared x. So what I did was basically this, I moved over to the other side. So when you're looking at the Pythagorean identities, it's every simple algebra manipulation of those three identities.
Ooh, that is a beautiful set of language you just used. Thank you.
You're welcome. So it's so like the one you were saying, the 1 plus cotangent squared x equals cosecant squared x.
Yes.
You can see the same thing as saying cotangent squared x equals cosecant squared x minus 1.
Okay.
So, but cosecant squared x plus 1 does not equal cotangent squared x. That's why the signs do matter on how you move things around.
So any true algebraic transformation of those three is acceptable. Oh, yep. Thank you.
You're welcome. That's why I say basically anytime you see a plus or a minus in the problem, you're probably going to go to a Pythagorean identity to get rid of it.
Understood.
All right, let's try one more of these, and then we'll go to problem type 3. All right, so this one got cosine x plus sine x tangent x equals secant x. All right. So now this one, the only thing I'm going to have to change is that tangent x. So I'm going to do cosine x plus sine x, and this is sine x over cosine x. And that's a quotient rule. Next thing I'm going to do is let's look at putting together, let's look at doing some algebra. So I've got cosine x plus sine squared x over cosine x. And that's an algebra step. Now let's put these fractions together. So I have cosine squared x plus sine squared x all over cosine x. And again, that's still an algebra step. Now, the cosine squared x plus the sine squared x on the top, that's my Pythagorean identity. So that's Pythagorean. And that right there, if I use the reciprocal rule, becomes secant x. So the hardest things about these problems, most of the rules are pretty easy to do. By changing things to sines and cosines, you can manipulate them quite a bit. It actually a lot of times comes down to your algebra steps. It's remembering, oh, to put fractions together, I need a common denominator. Like in this one, I had to put that cosine x under the first cosine x, which means the top one had to be cosine squared x. So it's manipulating your fraction in the algebra steps that tends to give these people the most trouble. So just try to focus on your algebra skills, really. So this cosine right here, if I wanted it over cosine on the bottom, the top has to be cosine squared x. Because if I divided those, I'd get back to my cosine x. And I wanted my common denominator to be the cosine x. Shrink this down. Typed it all in. So the first one is quotient rule. So cosine x plus sine x and then sine x cosine x. And that's quotient. Next two algebra steps I can put together. So top is going to be cosine squared x plus sine squared x over cosine x. And that's algebra. That's the other reason about writing it down before you type it all in, is it's going to save you typing in a bunch of extra steps that you don't have to. Now this one becomes 1 over cosine x, and that's Pythagorean. And then secant x, and that's reciprocal. So the first that's the problem type 1, it was just Pythagorean, an algebra and reciprocal or quotient steps put in. This one expands on it. You have to do the quotient steps, reciprocal steps, and maybe more algebra based built into it. And problem type 3 just gets a little harder. So let's go on to problem type 3. All right. So I've got 1, do it in. Don't worry, the screen's gonna be all white in a second. All right. Okay, whole bunch of more steps now. So What do you think you want to do first on this one? What would be your first inclination on how you want to start this one? They're all sines and cosines, so I don't have to switch anything. So, yep, we're going to make an algebra manipulation. What is it, though? It's the most hated algebra transformation.
Getting those denominators the same.
Yep, we got to get a common denominator, so we're going to put it all together. All right, so I got to get to this part over here. So we're going to ignore that. All I'm looking at is this stuff over here. I'm looking at that stuff right there. I got two fractions. I don't have any fractions in my answer. So somehow I got to get rid of my fractions. So let's get the two fractions so it's one fraction. That's a start. So my denominator is going to be 1 plus sine of x times cosine of x. My numerator is going to be 1 plus the sine of x squared plus the cosine of x squared. All right. So that's an algebra manipulation. Questions on how I got that? I will tell you, this is probably the hardest topic that you're going to have to do. So if you have questions on this, I don't doubt it. You just got to bug me. So all I did was I multiplied the bottoms. I multiplied that one times that one, and that one times that one. All right. So now the next thing I have to do, this is out of all the steps in algebra, this is the one that drives me the most crazy because foiling seems to be like the easiest thing in the world to do for a lot of people, and they always mess it up. So this part right here, when you foil this, you're going to have 1 plus 2 sine x plus sine squared x plus cosine squared x. So don't lose the middle term. Don't just square the two pieces. That 2 sine x is going to come into play in a little bit. If we don't have it, we're going to be in a little bit of a trouble. I'm not going to multiply the bottom part. I'm going to leave the bottom part alone for right now. So again, I just did an algebra manipulation. Now, let's look at this part right here. What's sine squared x plus cosine squared x?
One.
That's 1. So this whole top part up here becomes 1 plus 2 sine x plus 1 over 1 plus sine x cosine x. And that's a Pythagorean step. All right. Next. Those top parts can become 2. So it's 2 plus 2 sine of x over 1 plus sine of x cosine of x. And that's an algebra step. I have 2 2's on the top, so I can take out that 2. Remember how I said that 2 sine of x was going to come into handy? If we didn't have that, we wouldn't have been able to do this step. And that's another algebra step. Now, those 1 plus sine of x's can cancel out, and I'm left with 2 over cosine of x, which is just another algebra step. And then cosine of x is secant of x. And that's a quotient step. Oh, not quotient. Reciprocal step. And if I remember right, that was what I wanted. So that's my final step. So remember I was saying the hardest steps are all the algebra steps. This is why. None of the steps that we did there, like the trig stuff, was actually pretty straightforward and simple. It was the algebra steps that we did to get to the last parts. So in this step right here, I'm basically crossing off those two. And I'm left with the 2 over the cosine of x. Cosine of x, 1 over cosine of x is secant of x. So I just pulled the 2 out, looked at the 1 over cosine of x, which becomes that secant of x, and I put the 2 in front of it. So you can look at this step right here as 2, 1 over cosine of x, which goes to that. All right, now we have to write all these steps into this problem. I'm going to try to do this a little different. Okay. So we've got, when you're typing and when you have fractions, type the fraction in first, because this way you don't have to highlight to put the fraction thing back there. So 1 plus sine of x squared plus cosine squared x. Cosine x. Oh, actually. Yeah, let's do it. And now I have the 1. I actually could have put these two steps together. I just didn't. 2 sine of x plus sine squared. And you can highlight, you can't copy and paste on these. So when you're typing in a lot, like that bottom part, just copy and paste it down. It saves you the step having to rewrite it. The next step's the Pythagorean step. I'm going to actually do the 2 plus. I want to see if this actually lets me do it in one step. Because technically 2 plus 2 is not an algebra step. Good, it did. All right, so I just skipped doing the 2's together. And now I can skip, I don't have to type in that whole next step where I factored out the 2, because the next 2 steps are both algebra steps. So I only have to type in the 2 divided by cosine x step. And then it's 2 secant of x. And that's reciprocal rule. So I could have actually put these 2 steps together too and just put this one down here and saved me extra little bit of typing, but that's fine. It'll still check because every step that you did was correct when you typed them in. All right, we're going to do another one. All right. So we've got cosine of x over 1 plus sine of x equals secant of x minus tangent of x. All right. So somehow I don't have addition over here, and now I have addition over here. So this is one of those problems that sometimes it's actually easier to go backwards when you're trying to do the problem to get the actual steps to come up with the original problem. So let's look at this part over here. So we're going to look at this part over here this time. So, and we're going to try to get back to this. And then I'm just going to do my steps backwards when I type the problem in. So the secant is 1 over cosine of x. This tangent is sine of x over cosine of x. So that's just, actually that's 2 steps. I actually have to write that as 2 steps. So that'd be the quotient, or the quotient and reciprocal rule. So now I have 1 minus sine of x over cosine of x, which looks like it might help me a little bit, but I have a plus on the bottom and I have my cosine of x on the top. So somehow I've got to get the it reversed. So let's take and multiply it by 1 plus sine of x on the top and the bottom. So anybody know what that's called? So that right there, this step right here, is known as its conjugate pair. So whenever we're trying to take the problem on the and get rid of addition and subtraction and switch them up, sometimes multiplying by its conjugate pair will help do that. The reason why it works is because basically what it's going to do is it's going to cancel out my middle term, because it's the difference of 2 squares at that point. So now my bottom is, there's some things in math that are very inappropriate, unfortunately. 1 plus sine x is there. Now this top part, 1 minus sine squared x, is what? That is a Pythagorean identity. That right there becomes cosine squared x. So now I'm left with cosine x over 1 plus sine of x. And if I cancel those 2 parts out right there, I'm left with cosine x over 1 plus sine of x. Hey, that's what I wanted. Okay. So now the question is how do I get there? So I was able to do it backwards, fine. So now we've got to go, we've actually have to do it forward. So I know I have to use that conjugate pair part. So let's actually take that part out and do that. And that's where looking at the backwards sometimes helps, because going forward, you probably wouldn't have thought conjugate pair was the first thing to look at. So by doing it backwards, it kind of gave us that clue that we needed. So I'm going to do this, cosine of x times 1 minus the sine of x, and then 1 plus sine of x times 1 minus the sine of x. So now so that's just an algebra step. The top, I'm going to leave alone for a second. And the bottom becomes 1 minus sine squared of x. So again, that's just algebra. And now my bottom becomes cosine squared of x, which is the Pythagorean rule. And now we can cancel out my cosines. So I have 1 minus sine x over cosine of x. And that's an algebra step. And now, when I have a fraction on the top, when I have a fraction, I have addition and subtraction on the top, I can split those up. So I have 1 over cosine of x minus sine of x over cosine of x. And again, that's just algebra. But now I can actually go through and I can do my quotient and my reciprocal rule. So this first one's going to become secant of x. And remember, I have to do these as 2 separate steps. So that's my reciprocal rule. And then minus tangent of x, which is my quotient rule. That was why I said doing it on a paper, you have to. Because like this one, there's no way that you would have looked at that original problem and go, oh, I got to use conjugate pairs. But by going backwards, it's like I looked at the 2 sides like, wait, I need this here. And conjugate pairs are the only way to make that actually happen. All right. Now we've got to type the whole problem in. So remember, I only have to write the steps when they change. So I can do the cosine x, 1 minus sine of x. Conjugate pairs. You actually, it's more used when you're dealing with radicals. Is when you're trying to get rid of square roots and stuff like that, you do conjugate pairs quite often. Or and also when you're doing imaginary numbers and complex numbers. Because it gets rid of that the imaginary part. So that's algebra. And then I have my not conjugal, conjugate. And don't ask me to spell it. There's a reason I became a math teacher. Oh, I forgot the X. And now I can take the next 2 algebra steps and put those together. So I have 1 over cosine of x minus sine of x cosine of x. And that's algebra. And then you secant x, sine x, cosine x. That's reciprocal. And then minus tangent x. And that's quotient. And we complete it. So I will tell you the only way to get better at these is to do them. It's I've given you some of the tricks and some of the different things to look at when you're going through and doing it. But it's just honestly going to come down to you playing with them and figuring them out. There is no other way to actually really get better at doing them, unfortunately. All right. Let's go into our sum and difference identities. We're going to move out of the proofs for a few topics. So my sum and difference identities. So if we go over here, those are my sum and difference identities. So sine of A plus or minus B equals sine of A cosine B plus or minus cosine A sine of B. the order of the signs matter in this situation. So see how they've got the plus or minus right here? And they've got the plus or minus there. So if that's a plus, that one's a plus. If that's a minus, that one's a minus. Notice how in this next one, they switch. So if it's a plus on this side, on the left side, it's going to be a minus on the right side. If it's a minus on the left side, it'll be a plus on the right side. And the same thing on the tangent one. The top one matches, the bottom one is flipped. So do keep that in mind when you're looking at those signs on how to actually read those functions there. Now, when we're doing the problem, so this problem, it says find the exact value of pi over 12. So I've got sine of pi over 12. Now, there is no pi over 12 on my unit circle. So what I've got to figure out is I got to figure out which two angles on my unit circle are going to give me pi over 12 when I either add them or subtract them. Now, if we look at my unit circle, I've got the numbers, the ones I've got is got pi over 6, pi over 4, pi over 3, and pi over 2. Those are basically the ones that I have. And then we have the multiple numbers of the ones on top. So we have 5 pi over 6 and so on and so forth. So I've got to get pi over 12. Now there's no way to get that by addition because it's smaller. So I'm going to have to subtract 2 of those numbers to get pi over 12. So which two numbers would give me 1 pi over 12? So we have to try to figure out a combination. So first of all, I want a 12 on the bottom. So 6 and 4 would work. Actually, pretty much any of these would work to give me a 12 on the denominator. So let's make them all so there's 12 on the bottom. So this would be 2 pi over 12. This would be 3 pi over 12. This would be 4 pi over 12. And this would be 6 pi over 12. So to subtract and get 1, there's a few different options I can do. I can do 4 pi over 12 minus 3 pi over 12, or 3 pi and minus 2 pi over 12. Either one of those will work. So I'm going to do sine of pi over 4 minus pi over 6. So that's the one that's going to give me my pi over 12, because I'm going to have 3 pi over 12 minus 2 pi over 12, which gives me 1 pi over 12. Does that part make sense?
Yes, sir.
All right. Now we have to look at the rule for signs. All right. So Caleb, which part doesn't make sense? Which do you understand how I got them all to be the 12s, or how I figured out pi over 4 and pi over 6? And while you answer that, I'm going to write down the rule. Okay, so in my unit circle, I only have those 4 fractions basically. So I've got to somehow get it down to a pi over 12 using just those 4. Because on my unit circle, I only have so many values that I can actually get exact answers of. So when I'm looking at this one, plus, minus, I want to figure out ones that it's going to give me a 12. So I'm going to make them all have the denominator of a 12. So my common denominator is going to be 12. So 6, I had to multiply by 2. So that's how I got the 2 pi over 12. 4, I multiplied by 3. So that's how I got the 3 pi over 12. The 4 pi over 12 from the pi over 3, and then the 6 pi over 12 from pi over 2. Now it's just a matter of figuring out which one is going to give me pi over 12. So if I look down here, I just need 1 pi. So I could have, the ones I chose was these two, because 3 minus 2 is going to give me 1 pi. So 3 pi minus 2 pi is 1 pi over 12. So once we've got that, I'm just going to plug into that formula. So this is my sum and difference formula. So sine of x minus y is sine of x cosine y minus cosine of x sine of y. So now I'm going to go back to my unit circle, which hopefully you have printed or written down somewhere that you can use. And I'm going to use my values. So so x is pi over 4 and y is pi over 6. So now remember the sine is so actually I probably shouldn't have used x and y because it might make it a little confusing. Remember, sine is your y values. So pi over 4 is square root of 2 over 2. And cosine of pi over 6 is square root of 3 over 2. Then it's cosine of pi over 4, which is square root of 2 over 2. And sine of pi over 6, which is 1/2. So I just got those values right from my unit circle. So this gives me square root of 6 over 4 minus square root of 2 over 4. So I get square root of 6 minus the square root of 2 over 4. Questions?
Yes. Can you show us how to take these, maybe a little bit off topic, but it's like simplifying a radical. The square root of 3 minus 2 root 2. Like the square root of all of that, like the square root of 3 minus 2 root 2, and turn that into a perfect square to simplify that.
I'm trying to figure out what your question. I'm trying to figure out like what you're asking. So the way that so this problem you can't. This problem you can't put together. There's no way to do it.
Right. I mean, like specifically, like, kind of use the. I forget exactly the method. Right, like, can you simplify that? I know what the answer is, but I don't quite know how to get there. The answer that the Alex told me was that it was root 2 minus 1, but I'm not sure how to get there.
Okay, so there's two things I think that let's look at two things. First thing is to simplify down to square root, depending on what you have, we want to basically do factors. So this one is 49 and 2. So this problem right here, that 49, the square root of 49, the square root of 2, that's 7 root 2. So that's the first thing you can do. So if you can break down a root and actually be able to factor stuff out of it, you can break it down into a little simpler terms like that. All right. The one we just did was square root of 6. I can't break down the square root of 6. So there's nothing I can do with that one. Depending on what. So you said your final answer is root 2 minus 1.
Yeah. It's like they used some sort of like what's that? I was looking it up online. They use some sort of what is that called? The x squared plus 2ab plus b squared. But I'm not quite sure. So my answer was the square root of 3 minus root 2.
Okay.
No, all under the radical.
Oh,
The
okay.
root 2. And then it said sorry. Like when they finally told me the answer, it was root 2 minus 1.
Okay, so it was like that?
Yeah, and I tried looking up online, and they used some sort of a form like the like x or ax squared, like some sort of like a parabola, or I forget. I don't know how they got to root 2 minus 1. Somehow they factored it, and it came out to the right answer was root 2 minus 1.
Yeah, I have a feeling. So I think. All right. So I think the problem is actually not this. The problem is what you had prior to this. So I think the steps you got to get this part, if you did it a different way, you probably would have come out with the square root of 2 minus 1. Because I can't quickly see a way to get that to turn into the square root of 2 minus 1. Because you basically have it's the fourth root of 2.
Like the way that it was factored was like it's actually like 3. It's actually like 3 plus 1, or it's actually like 2 minus root 2 minus, or like let's see, like 2 squared minus 2 root 2.
All right, so here's what I'm going to tell you to do, because
I forget.
It's okay. If you can find the problem, even if you have it in your notes, take a picture and send it to me.
Oh, I don't. Okay, I will.
It's very possibly that like a perfect square or something simple like that. So yeah, if you can find it, just take a picture of it, and I can show you the steps. Because like there's a piece missing to get from where you are there to the answer, and
okay.
Yeah, the problem is you can't and that's what I'm saying. I think that the step is missing because that's not a perfect square binomial in any stretch of the imagination. Okay. So there's a step missing in there somewhere. So just if you find the problem, just take a picture of it and I can go over it with you. That's not a problem.
Okay.
All right. Let's see. I think there was one more of these. Yeah, let's do one more. There's one more of this topic. All right, so this one. So if you notice on the first one we did, they're giving me the one piece, and we have to split it apart. In this one, they're giving me two pieces, and I have to put it together. Well, that's the first thing I'm going to try. The second thing I'm going to try is we'll actually break the pieces out. But let's actually try to put it together first. So this is subtraction. So if we're looking at my rules, this one's sine, cosine, cosine, sine. So this is actually the sine rule. So this is sine of x minus y. So I've got 3 pi over 7 minus 5 pi over 28. So this would be, I got to multiply this one by 4, so I got 12 pi over 28 minus 5 pi over 28, which is 7 pi over 28, which is pi over 4. So all I'm doing is the sine of pi over 4, which is square root of 2 over 2. So when you're looking at this topic, a lot of it is just going to be it's all fraction work. It's literally putting the fractions together, getting common denominators. Let me do one of the other ones actually again. Actually, we're going to do the proof ones next anyway, and you have to do them again that way. So we have one problem where we're splitting it apart. That's what we did in this problem. we were taking the pi over 12 and we had to break it apart. And then in this topic, we had to take the two fractions they gave us and put them together. So both those topics using the sum and difference formulas. Both these were both the sine ones, but you can see it with the cosine and the tangent ones. It's the same process. It's just a different rule. So just making sure to look at the rules as they're written down, and you should be fine with those. All right. I'm running out of time, so I want to get at least the last couple proof ones down. All right. So now this topic, again, it goes back to the proofs again. It's using the sum and difference formulas now instead of just the other rules. So if we look at the rules, you'll see sum and difference here now. And the same concept. So if you don't remember the rules, if you click that little I, it gives them all to you. And notice how they break them up. So you don't have it just as the 6 like my cheat sheet does. With the 3 rules, they have it as broken up into the 6 rules. So let's write the problem down and go through all of the steps. Cosine x plus y, cosine x, y, 1 minus tangent x, tangent y. All right, so cosine of x plus y, if we look at the sum and difference formula, so that's going to be cosine of x, cosine of y, and it's a plus, so this is going to be minus sine of x, sine of y over cosine x, cosine y. So that's the sum and difference rule. Now, when we have addition on the top and over a fraction, I can split that up and put the fraction under each one. So this becomes cosine of x, cosine y over cosine x, cosine y, minus sine x, sine y over cosine x, cosine y. So that's just algebra. And canceling out that first one is also just algebra. And now this one, sine of x over cosine of x and sine of y over tangent of y or cosine of y is tangent of x, tangent of y. And that's the quotient rule. There's 2 types of this problem. This is problem type 1, so obviously it's easier of the 2 groups. Does that process make sense on this one though? Okay. So now let's type them in. Cosine x, cosine y. So the rule for cosine x, cosine x plus y is, give me 1 second, I'll actually show it up on the screen. I just got to finish typing this in. So if we look at the sum and difference rule, the cosine u plus v is cosine u plus cosine, or cosine u cosine v minus sine u sine v. So that's what I did with that cosine x plus y. I just changed it into cosine x plus cosine y, or cosine x cosine y minus sine x sine y. So it's just using that sum and difference rule. And then the next two steps are algebra, so I don't have to type them both in. I can just type them one in. And then I can just do the 1 minus tangent x tangent y. And that's quotient. That's why writing them down is very helpful when you're doing it, because you can combine a bunch of steps when you actually type them into the problem. All right. So in this topic, you'll also notice a term called evaluation in here. Evaluation is where you actually do a calculation. So because of this topic, we're going to need that. Because you notice I have pi over 3 in this problem. It's not just all x's. So we're actually going to have to evaluate those and get an actual value. And that's going to be part of this problem. So I have cosine of x plus pi over 3 plus cosine of x minus pi over 3 equals just cosine of x. All right, so when we're looking at the cosine, so again, we go back to the rule. So cosine of, actually, let's not use x. U plus or minus v is cosine of u cosine of v, and it's minus or plus this. I got to move it over. Sine of u sine of v. So it's going to be switched. So this cosine of x plus pi over 3 is going to be cosine of x cosine of pi over 3 minus sine of x sine of pi over 3. And then plus cosine of x cosine of pi over 3 plus sine of x sine of pi over 3. So that's my first step. And that's just using the sum and difference rules. The rule that I just wrote there. Now, if you look at this, that and that are exactly the same, and one's a plus and one's a minus. So they cancel each other out. So I have cosine of x cosine of pi over 3 plus cosine of x cosine of pi over 3. And that's algebra. Now I want to get rid of that cosine of pi over 3. So if we look at my unit circle, cosine of pi over 3 is 1/2. So this becomes 1/2 cosine of x plus 1/2 cosine of x. And that's an evaluation step. And then we put them together and we're left with cosine of x. And that's an algebra step. So by changing the cosine of pi over 3 to 1/2, that's evaluation. Putting them together, that's an algebraic. Those steps make sense? Again, like I said, a lot of this is just going to come back to just going through and trying the topics out. If you get totally and utterly stuck on one when you're doing it out, just in the Alex, use the help or mail button and mail me that problem. Because for me to actually help you with the problem, I'm going to have to actually see it. And this step was sum and difference. And then we combine things. So I've got cosine plus that. It's algebra. Then we got 1/2 cosine x plus 1/2. And that's evaluation. And then I have cosine of x. And that's algebra. So again, it's just using those sum and difference rules to split things apart and put them back together. And once you look at the rules, a lot of it is just figuring out the steps for it. Yeah, so the evaluation step is just using the unit circle. So cosine of pi over 3 is the x value of the pi over 3, which is 1/2. So whenever they're looking at evaluation, they're always going back to that unit circle to get the exact value of that function. So if we look at here, real quick. So there's the unit circle. So pi over 3, the x value is 1/2. We didn't get rid of the 1/2. We actually put them together. What's 1/2 plus 1/2 is 1. All right, that one. 2 more rules. All right, so the next topic is the double angle formulas, and then we have half angle formulas. So again, these just go back to rules. So if we look here, these are the double angle formulas. So these are ones right over here. So we're going to use those to do some calculations, basically. We have to look at the rule and then look at the problem that they gave us to figure out what we're going to be using. So actually what I'm going to do It's the Trig cheat sheet. It's right on my website. It's right under the link to the team meeting. All right, so go back here, back to the problem. All right, so in this one, they're giving me my cosine of x is 5 over 13. So they're telling me my cosine of x is 5 over 13. So this is my x over my r. So the first thing we need to find is I need to figure out my y. So I have to do my Pythagorean theorem. So I have 5 squared plus y squared equals 13 squared. So 25 plus y squared equals 169. So y squared equals 144. So y equals plus or minus 12. Since we're in the fourth quadrant, so x is going to be 5. Y, since it's in the fourth quadrant, is going to be negative 12, and r is 13. So now I just got to figure out each of my functions. So I've got cosine. So cosine of x is 5 over 13. Sine of x is negative 12 over 13. And tangent of x is negative 12 over 5. So those are my 3 functions that I'm going to use. So sine of 2x is 2 times sine. So I've got negative 12 over 13 times cosine. So 5 over 13. Cosine of 2x is cosine, or you can use any of those that you want. Doesn't make a difference. So I'm going to use the cosine squared and sine squared. So I've got cosine squared, which would be 25 over 169, minus sine squared, which is negative 144 over 169. And then tangent squared, or 2x, is 2 times tangent, which is negative 12 over 5, divided by 1 minus 144 over 25. Oh, and actually, that's not a minus 144. It's a positive 144. So now we just got to basically do the calculations on these to simplify them down. So this top one is going to be over 169. So 2 times 12 times 5. So it's negative 120 over 169. 25 minus 144 is 119 over 169. This one's a little more complicated. Negative 24 over 5 over negative 119 over 25. So I get 24 times 25 is 600. And then 5 times 119 is 595, I believe.
You were 2 for 2. Those are both correct.
Very good. Thank you for double checking. So 169, negative 119 over 169, and 600. Oh, that they're going to yell at me. Let's see if they yell at me, because this one can be reduced. Nice. They don't yell at you if you didn't reduce it. That's handy. So that's basically all you're doing for this one. You're just going through and plugging them into that formula. So the piece that you have to do to it first is you have to find your x, y, and r, find your cosine, sine, and tangent, and then plug them into those three formulas, your double angle formulas. And the last one, half angle formulas. Same concept, just a different set of formulas. Let's see if we have the half angle ones on here. Yep. All right, so we have our half angle formulas. They're going to give you a variety of different ones. So this one, they gave you pi over 8, and they're just going to get tangent. So if you notice, I don't have a pi over 8 on my unit circle, but I do have pi over 4. And if I took pi over 4 and divided it by 2, I would get pi over 8. So that's what the half angle formula does. It allows me to take basically half of any of those angles and do the calculations for them. So when I'm doing my calculation for tangent, it's we can use either one of these, but we're going to use the first one. So it's plus or minus the square root of 1 minus cosine of pi over 4 over 1 plus cosine of pi over 4. Now cosine of pi over 4 is square root of 2 over 2. So I have plus or minus the square root of 1 minus the square root of 2 over 2 over 1 plus the square root of 2 over 2. So this one right here, the top becomes 2 minus the square root of 2 over 2 over 2 plus the square root of 2 over 2. So 2 minus the square root of 2, 2 times 2 over 2 plus the square root of 2 over. So I get 2 minus the square root of 2 over 2 plus the square root of 2. Now, remember why I said those conjugate pairs and stuff come into play? They're going to come into play here. So I'm going to multiply the top and the bottom by 2 minus the square root of 2. So the top, so the bottom is basically going to become 2, it's going to be 4 minus 2. So the bottom becomes just 2. The top part, so top becomes 4 minus 2 square root of 2 plus 2. So it becomes 6 minus 2 square root of 2. So this whole answer becomes the square root of 6 minus 2 square root of 2 over 2. And I'm wondering if this is actually where you were getting that original problem from. So I get 3 minus the square root of 2. Let's see if they actually take this as an answer. So 3. All right. Oh, they're using a different rule. Was this the problem you were talking about earlier?
It was the tangent of 7 pi over 8, but yeah, and I saw how they factored it. I ended up doing a lot of research to figure out how I would factor it, and they took the common formula that a squared plus 2ab plus b squared equals a minus b squared. And this was a guy from like Cornell University that was teaching it, and specifically it was this specific problem, the square root of 3 minus 2 root 2.
Yeah, so the easier way to do it is you're not actually trying to change that into the other one. And this is where they actually had the different rules than what I was using. And they have this one, which is the easier one to use, which is sine of it over 1 plus cosine of it. So you're not dealing with the square root at all. That's how they actually were able to do it. And I just closed everything. That's how they were actually able to get the square root of 2 minus 1, is because they actually didn't use the square root problem that I was using at the beginning.
Now they mentioned, like, I got to the same page, and they were saying something like, oh, well, we chose this formula because so we don't have to deal with the plus or minus.
Correct.
I wasn't sure why, like, they were choosing one over the other. Like, how do we get to choose?
So it really comes down into which quadrant it's in. So tangent of pi over 8 is in quadrant 1. Quadrant 1 is going to be positive for tangent. So you have to look at your quadrants and figure out which one it was going to be in. That's why the square root 1, you wouldn't have both answers. You're only going to use the positive one because quadrant 1, which where pi over 8 is, tangent is always positive.
So, like, whether we use the sign on top or the one with the sign on the bottom, does it matter what quadrant our angle is in?
Nope. Both of them will come out to be the same. Both of them will come out to be the right answer.
Okay, but you just have to look and know which
one. Yeah, yes, you have to look at your quadrant. So 7 pi over 8, that's in the second quadrant. So it's going to be the negative version of it because tangent's negative in that one.
Got it.
Okay. All right. And on that note, it's 7:50 and we're past time in the class, so I'm going to end it here. Don't worry, we'll be doing more of these on Wednesday anyway. So we'll do some more proofs and stuff on Wednesday, and the rest of section 1 for chapter 7 and 8 on Wednesday. And then next week we'll be doing the other 2 parts of section 2. So if you do have any questions on these, like I said,